Okay, today we're going to go over limits with wholes and conjugates. So what's going to happen is we're not going to just be able to plug in the x value and get an answer. What's going to happen is when we're evaluating the limit, so when we're plugging in whatever x is approaching, you're going to get 0 over 0. Okay, that means there's a hole in the graph. Okay, so we're going to find the limit. There's going to be several things we do or we can do. What we're going to focus on today is factoring, if it's something we can factor, or if there's square roots, I'm going to multiply by the conjugate. Okay. So the first thing you want to do anytime you're working them, so to evaluate this limit, that just means plug in the number. Okay, so step one is always plug in the number. So if I plug 2 into this, 2 squared is 4, minus 2 times 2 is 4, so I have 4 minus 4 over 2 minus 2. That gives me 0 over 0. Okay, so you still always want to plug it in first, because sometimes you will get a number, like on the ones we did earlier. Okay. So if you do get 0 over 0, if it's something that just looks like our regular x polynomials, you want to factor it. So on top, I want to factor out an x. So I'm going to take out the GCF. And I'm left with an x minus 2. Okay, so anytime you get 0 over 0, once you factor, you should always be able to cancel something, and you're just left with an x. Okay, so what we're going to do now is reevaluate the limit as x approaches 2 by plugging 2 into what's left. So if I plug 2 into x, it's just going to be 2. So that will be our limit. On this next example, we've got the limit as x approaches -1, okay, of 2x squared minus x minus 3 over x plus 1. So the first thing I'm going to do is plug in -1, and I can see on the bottom, -1 plus 1, that's going to be 0. Okay. On the top, -1 squared is going to be positive 1 times 2 is going to be 2. And then minus a -1 is going to be plus 1 minus 3. Okay, so I'm going to have 3 minus 3, 0 over 0. Okay, and everything we get today in these examples is going to be 0 over 0, but you still always want to plug it in first because your examples are all going to be mixed in together. So sometimes you will be able to plug it in and actually get a number that is not 0 over 0. So since I got 0 over 0 on this one, I want to factor. So I'm going to factor 2x squared into 2x and x. I'm going to factor the minus 3 into -3, positive 1. That will give me 2x minus 3x. That's going to add up to the negative x. Okay. All over x plus 1. Okay. So now I can cancel the x plus 1. So I'm left with 2x minus 3, and so now we can go ahead and evaluate the limit by plugging in -1. So if I plug in -1, that's 2 times -1 minus 3. That'll be -2 minus 3, which is -5. So those are just our normal factoring ones. These look like polynomials we've seen all year long. The other type we're going to have today are ones with square roots. Okay, so we've got the limit as x approaches 4 of root x minus 2 over x minus 4. So if I plug in 4, square root of 4 is 2, so that's 2 minus 2 over 4 minus 4. Again, going to be 0 over 0. Okay, so with these square root ones, what you want to do, I'm just going to recopy this expression. Okay. Wherever you have the square root, you want to multiply by the conjugate. Okay, that means change the sign between the square root and the regular number. So what I'm going to do is multiply by square root of x plus 2. Okay, and so to keep this fraction equal, I've got to multiply by that on top and bottom. Okay, so on the top, I want to FOIL this out. So square root of x times square root of x is just x. And then you can skip the outside and the inside with conjugates. With conjugates, you only have to multiply the first and the last. So -2 plus 2 is going to be minus 4. Okay, so you always want to multiply out the conjugates. And then these you just want to leave separate. You want to leave it as x minus 4 times root x plus 2, because then I'll be able to cancel the x minus 4s. You should always be able to cancel a factor, and we're canceling the x minus 4 because that's what gave us 0 when I plugged in 4. So anytime it's a 0 over 0 type of limit, which means there's a whole, okay, if there's square roots, we multiply by the conjugates, and then we should always be able to cancel something. And then you look at what you're left with, okay, and then at that point, you can evaluate the limit. So now I can plug in 4. So that's going to be 1 over the square root of 4 plus 2, which is going to be 1 over 2 plus 2. So this limit is going to equal 1/4. So let's do 2 more square root examples. So I have the limit as x approaches 9 of the square root of x minus 3 over x squared minus 8x minus 9. So again, I'm going to plug in 9. That's going to give me square root of 9 is 3 minus 3, so that's going to be 0. Over on the bottom, that's going to give me 81 minus 8 times 9, 72, minus 9, which is also going to be 0. Okay, so 0 over 0. So since this has a square root in it, I'm going to multiply the top and the bottom by the conjugate. So change the sign between the square root and the number. The top is where the conjugates are. This is the minus 3, the plus 3. So the top is what I want to multiply out. So when I multiply that out, that's going to give me root x times x. Root x times another root x is just x. Negative 3 times positive 3 is going to be minus 9. Okay. On the bottom, this trinomial, since it's not factored, I want to go ahead and factor it so that I can cancel something. So this is going to factor into x minus 9, x plus 1. That'll multiply to negative 9. The negative 9 plus 1 is going to add to the negative 8. And then I also have this square root of x plus 3. Okay, so don't forget when you multiply by the conjugate, you got to multiply on top and the bottom. And then, now that you've multiplied these out, I can cancel the x minus 9. And I'm left with 1 over x plus 1 times the square root of x plus 3. And now I will be able to evaluate the limit when I plug in 9. So plug in 9, you're going to get 1 over 9 plus 1, that's going to be 10, times square root of 9 is going to be 3, so 3 plus 3 is going to be 6. So our limit is going to be 1 over 60. And now let's go ahead and go over one more example. Okay, so we've got the limit as x approaches 0 of 2 minus the square root of x plus 4 over x. Okay, so if I plug in 0, I can see I'm going to get 0 on the denominator. If I plug 0 in here, that's going to give me square root of 4, which is 2. So I'm going to get 2 minus 2 in the numerator, which is also going to be 0. So again, I get 0 over 0. Okay, so what I want to do, here's where the square root is. So I just want to change the sign between the regular number and the square root. So since it's minus, I'm going to change it to plus. And I'm going to multiply by that on the top and the bottom of this fraction. Okay. So the top part is the ones I need to multiply out. Okay, so I've got 2 times 2 is 4. Minus, when I do x plus 4, root x plus 4 times another root x plus 4, that's just going to be x plus 4. But since I'm subtracting this, and I'm subtracting because it's a negative times a positive, I'm going to have to distribute in that negative sign. So when I distribute this negative on top, that's going to be 4 minus x minus 4. So the 4 minus 4, these are just going to cancel each other out. So I'm left with a negative x on top and then x times 2 plus the square root of x plus 4. So make sure on the top, make sure you distribute combine like terms before you cancel anything out. You can't cancel anything at this step right here. You've got to simplify the numerator, and then I'm able to cancel the two x's. So now I will be left with a negative 1 on top, and then 2 plus the square root of x plus 4. And now when I evaluate the limit by plugging 0 in again, I won't get 0 over 0. So if I plug in 0, that's going to give me 2 plus the square root of 4. Okay, square root of 4 is 2. So I'm going to have negative 1 over 2 plus 2. So for my limit, I'm going to get negative 1/4.